Hello, for those of you who don't know me, I'm Andrew and I'm talking on behalf of Group Kilo about our project, the Key Locator. We were set the challenge of doing an indoor positioning system based on image recognition for situations where things like GPS doesn't work. So we were given a very open project brief to start with. We sat down as a team and worked out what we wanted to be able to do. So we came to the conclusion that a successful acceptance criteria would be to locate the user to a specific room. For example, we're in Lecture Theatre 1 at the moment. You can't actually test it because the Wi-Fi is dodgy here, but trust me, it does work if you had a look at it before. We said we try and guarantee 80%, which we hope we've been able to do. We also had to keep in mind how it would scale up to any number of buildings and any size of buildings, so we'll come back to that slightly later. This is a list of the technologies that we used. We decided to go for a client-server relationship. The client is on an Android mobile phone here. You take a picture of where you're lost or where you're trying to find out, and you send it off to the server. Server sits around, does some black magic in the background, and sends back a position saying, you're probably in Lecture Theatre 1. The client then takes it, has a look at it, gives you a map showing where you are, and then provides useful features. You can do path locating to the nearest toilet or the nearest exit, or to the nearest specific room if you're trying to find a supervision room, for example. Okay, this is how the magic works. This shows one of our early implementations of the image recognition, and it shows some of the advantages and disadvantages that we had, so I hope you can see what we were trying to overcome. Notice in the lower images that generally bits of circles map to other bits of circles, and bits of lines map to other bits of lines. This is okay, but the image recognition called SIFT, which is Scale Invariant Feature Transform, sees one bit of circle the same as another bit of circle, so we had to work out a way to come around that. The other thing you can notice, particularly with things like these here, that it maps multiple points to the same point on another image. So we did a strict enforcing of one-to-one correlation between the two to hopefully try and make it slightly better. What we have is a server that can run on pretty much any computer. All that is required for the system to work is someone beforehand to go and take pictures of the area they want to do and give the pictures as a database to the server. The server will then do a bit of pre-computing on them. After that, all you need is Wi-Fi and a client a suitable client that can run our code. So as far as that goes, it's not very infrastructure heavy. The server, as it stands, already works with multiple clients at the same time, and the workload increases linearly with the number of clients and the size of the database, so it's not particularly bad in that regard. You can throw more hardware at it, make it run faster. But back to the image recognition. Basically what we found is there have been several PhD research projects into trying to do similar things, and basically they've failed. To put it bluntly, what we've shown is that we have a basic proof of concept that works, but it needs a bit of refinement to make it more reliable. The fundamental problem that we've got is we cannot geometrically match two images. There was one branch into the field that did this. It was known as auto-stitching, where it takes a set of images and does a really nice bit of maths, uses a lot of statistics, not particularly healthy, and sits around and generates a panorama, which is absolutely fantastic, but unfortunately it's based on the fact that the camera stays in the same position. So more research would go into the fact of generalizing that to not require the camera to be in the same positions. So, whilst we were fixing the server, the client people copiously came up with pathfinding and this picture, which might amuse you. I'd like to say thanks to Billy Gibson for standing in to be our client, to Andrew Rice for letting us borrow his phone, thank you wherever you are, and to the rest of Kilo team for forcing me to stand up and do this presentation. Thanks.